What's up, everybody? In this video, we are going to learn how to connect a button to the Arduino and read the value of an input. We will then control an output based on the input value. The components we will use are a push button for the input and an LED for the output. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our basic setup circuit that we made in an earlier video. Hover over the circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our circuit in the top left corner and change the name to LED-Pushbutton with code. Select a button from the components and add it to the breadboard. Remember that the terminals on each side are connected to one another. So side 1, terminal A, is connected to side 1, terminal B, and side 2, terminal A, is connected to side 2, terminal B. When you press the button, it connects the two sides. The goal is to have the Arduino read a high value when the button is pressed and a low value when it is not pressed. Connect a red wire from the power to terminal 1A. Add a green wire from terminal 2B to pin 2 on the Arduino. Now, when you press the button, the Arduino will be able to read a high value. However, when you release the button, the connection links to nowhere, meaning that the Arduino will receive a floating value. If the value is left floating, the Arduino could read this as a high or low. To solve this, we will use a pull-down resistor. This is a resistor connected between the pin and ground, which pulls the pin to a low value. Select a resistor from the components and connect it from terminal 2A to ground. Change the resistance to 10 kiloohms. Great! We now have a pull-down resistor, and the Arduino will be able to read either a high or low value. You might be wondering, why do I need the resistor? Can't I just connect one terminal of the button to power and one to ground? Do not do this. The reason is that as soon as you press the button, you will connect power directly to ground and create a short circuit. This can harm your components or Arduino. Our button is our input. Now we will add an LED as our output. Select an LED from the components and add it to the breadboard. Remember that we need to have a resistor to reduce the current flowing through our LED. Click on a resistor, rotate it using the R key, and place it onto the breadboard. Change the resistance to 220 ohms. Add a black wire that connects the cathode of the LED to ground. Last, add a yellow wire from the resistor to pin 3 on the Arduino. Great! Now we will add code to read the value of the input and send an output. Click on the Code tab and ensure the text drop-down is selected. Fill out the information in the header of our code. Update the program name and description. The program name is LED Pushbutton with code, and the description is a sketch where we will read a digital input to control an LED output. Let's start by reading the input value of the button. First, declare the variables for the button. Remember that variables enable us to have greater flexibility with our code. Let's create two variables. The first will hold the value of the Arduino pin connected to the button. Type int button pin equals 2 semicolon. Next, we will declare a variable to hold the state of the button, our input. Since it is digital, the state can only be a 0 or 1, or low or high. Type int button state equals 0 semicolon. In the setup function of our code, we need to tell the Arduino that the button will be an input. Underneath the serial statements, add pin mode, open bracket, button pin, comma, input, close bracket, semicolon. You may recall that we previously used the pin mode function to identify an LED as an output. Next, in our loop function, we will read the value of the input and print the value to the serial monitor. We will use the button state variable to do this. Each time the program executes the loop, the value of the button state will change depending if the button is pressed or not. Type button state equals digital read open bracket, button pin, close bracket, semicolon. You may recall we used a similar function called digital write. In that case, we were sending an output. In this case, we want to read an input, hence read instead of write. Next, add serial.println, open bracket, button state, close bracket, semicolon. This will print the value of the button state to the serial monitor so we can debug. Click Start Simulation and ensure the serial monitor is visible. You should see the value 0 repeating until you press the button. When you press and hold down the button, the value should change to 1. Click Stop Simulation. Let's add code for the LED. First, add a variable for the pin. In the variable declarations, type int LED pin equals 3 semicolon. In the setup function of our code, we need to tell the Arduino that the LED will be an output. Add pin mode, open bracket, LED pin, comma, output, close bracket, semicolon. Last, in the loop function, add digital write, open bracket, LED pin, comma, button state, close bracket, semicolon. With this line of code, we are controlling the LED by using the button state. So when we press the button, the LED will turn on, and it will turn off when the button is not pressed. Click Start Simulation and ensure the serial monitor is visible. You should see the value 0 repeating and the LED is off until you press the button. When you press and hold down the button, the value should change to 1 and the LED will turn on. Click Stop Simulation. Now is a good time to explore how code and the Arduino work with one another. In the loop function, set the delay to 5,000 milliseconds, or 5 seconds. Also, remove the comment lines from the serial.println statements at the start and end of the loop function. Click Start Simulation and press and hold down the button until the LED lights up. When the LED turns on, release the button. You should have noticed a couple of things. It took some time between the press of the button and the LED to light up. In addition, when the button was released, the LED stays lit for some time. So what's going on here? This has to do with how the delay function works on the Arduino. During the delay function, no other reading of sensors, mathematical calculations, or pin manipulation can go on. In effect, the code is paused until the end of the delay. This is known as blocking code. For simple sketches and short intervals, the delay function is okay to use. In a larger programming sense, the concept of blocking and non-blocking code becomes an important concept to help understand how a program executes its code and how you debug your programs. Blocking code executes synchronously, while non-blocking code executes asynchronously. For this course, most of our code will be blocking, as I feel it is easier for beginners to understand and debug blocking code. However, if you want to continue programming, learning about non-blocking code is a good next step in your career. Go back to your code and update the delay to 50. Click Start Simulation. Now, you will notice that the button is very responsive. There's still a piece of blocking code, but it only occurs for 50 milliseconds before the loop starts over again and reads the updated value of the button. 50 milliseconds is a very short amount of time, and most humans will not be able to detect the delay. At the end of this video, you should have a better understanding of a pull-down resistor, how to read an input on the Arduino, and blocking versus non-blocking code.